Okay, let's do some examples where we see how this works. So we want to know how many moles of hydrofluoric acid are produced if 1500 kilojoules react. So my given, my known, is kilojoules, and my unknown is moles. So let me go check the map. My first box is going to be kilojoules, and then box number 2 is going to be moles. And to get there, I'm going to use coefficients from the balanced equation. So let me make my boxes. We said box number 1 is kilojoules, and box number 2 is moles. And if I carry these over diagonally, I'm going to put kilojoules on the bottom. So you're known what they give you in the question always goes in the first box, every single time. So now my map says I'm going to look at this balanced chemical equation for the rest of the numbers. So let's see. My enthalpy, my kilojoules, we're going to do 542. I'm going to drop the negative because I'm solving for moles. And if I'm looking for HF, there's 2 moles of that. So I'm going to put a 2 right there. If I was doing H2, I would use a 1 because there's no number there, but I'm not, so I'm going to use 2. So when we plug this in, we're going to have 1500 times 2 divided by 542. And we can go calculate that. Let's see, 1500 times 2 divided by 542, and we get 5.5. So that means my final answer is 5.5 moles. All right, let's try a harder one. So this time they want to know grams of HF if we had 500 kilojoules react. And let's go see the map, see what we're going to do. So I'm starting off with kilojoules again. The only place I can go for box number 2 is moles, but I don't want moles. I want mass. So box number 1 is going to have kilojoules. Box number 2 is going to have moles. And box number 3 is going to have grams. All right, let's see. We said box number 1, we're going to put kilojoules. Box number 2, we're going to put moles. And box number 3, we're going to put grams. And I'm going to slide all of these letters down diagonally. There's no numbers, so I'm not going to worry about any numbers yet because the numbers are going to be different, but I can slide the letters down. So my given always goes in the first box. My map says use the coefficients from the balanced equation when I'm going from 1 to 2. So let's see, my coefficients, and looking at my balanced equation, kilojoules is 542. And moles, I'm going to use 2. Again, if I was using either one of these, I would use 1, but I'm not. I'm using 2 because I have HF. And for the last part, it says that we're going to use 1 mole is molar mass. And molar mass is the hardest one of these because we have to do an extra step. I have to find my molar mass of HF, so I'm going to add these up together. 1 mole and 19 plus 1 is 20. So we're going to multiply these and then divide by the bottom. So when we plug all of that in, we get 36.9, so roughly 37 grams. You can say this is approximately 37 grams. Alrighty, so let's try this one's a little bit harder, similar but an extra step, because let's see, they give us grams, but they want joules. Well, my enthalpy is in kilojoules, so I don't have to do an extra step to turn the kilojoules into regular joules. So they gave us mass, so that's what we're starting with. That's what box number 1 is going to be. If I follow my map down the line, box number 2, that's going to be moles. And if I keep going, because I don't want moles, I want energy, I can get to kilojoules right there. And then the last step will convert to joules with our other conversion factor. So we're going to have grams, moles, and then energy. So there's my grams in box number 1. Box number 2 gets moles. Box number 3 gets kilojoules, but I want regular joules. So that's box number 4. And then I'm going to slide all of these guys down. And then we'll fill in the numbers. So given always goes in the first box. Then my map say I'm going to use 1 mole and my molar mass. Anytime we have to do grams, we have to find the molar mass. So 1 mole, and we said that our molar mass, 19 and 1 is 20. So my map also says I'm going to get some coefficients from the balanced equation. So let's say my enthalpy, that's what I'm going to put for my kilojoules. And my moles from my balanced equation, that big number in front of HF, that's going to be 2. But because I don't want kilojoules, I want joules, I have to do this extra step right here. So I'm going to put 1 on the bottom with the kJ and 1,000 with the regular J. My grams cancel, my moles cancel, my kilojoules cancel. I'm left with joules. We are good to go calculate. So when I plug that into my calculator, I get 135,500 joules. And that is the same thing if let me go back. If I had a decimal point right here and I moved it 1, 2, 3, 4, 5 times, this would be 1.355 times 10 to the 5, because I moved it over 1, 2, 3, 4, 5 times. All right, we got 2 more problems and then you're on your own. So here they want to know, we produce 972 kilojoules of heat. How many grams of hydrogen must react? Well, like always, let's go check the map. How do we get there? I'm starting off with kilojoules. Then the only place I can go next is moles. But I don't want moles. I want mass. So box number 1 is energy. Box number 2 is moles. Box number 3 is grams. Energy, moles, grams. Then we drag everybody down. And then we plug in the number. So our given always goes in the first box. I'm going to look at these balanced equations to get from energy to moles. So let's see. My balanced equation has this much energy, so 243. And H2, because that's what I'm looking for, we're going to use 2 for the moles because there's a big old 2 in front of it in that balanced equation. And now the last step, we're going to use 1 mole with the molar mass. 1 mole, and H2, hydrogen has a mass of 1, so if I have 2 of those, I'm going to have mass 2. So then we're going to multiply all of this together and divide by the bottom. So when I multiply all of this out and then I divide by my enthalpy, we get a total of 16. So that means that we should get 16 grams of H2. All right, final question, and then that's it. So we've got this guy right here. This is called ethanol. It's a type of alcohol that they use in alcoholic beverages. But if ethanol is exposed to high heat, it's going to break down or decompose into these elements. Well, since we don't want that to happen, distillers use 177 kilojoules instead of 456. So because distillers use 177 kilojoules of energy to separate our ethanol from impurities, a typo, there shouldn't be an N right there. We want to know, we're still going to see a little bit of decomposition. So let's see how many grams of hydrogen gas are we still going to get even after we reduce the heat to this much. So this is, again, it seems complicated, but it's not. You have a given. Your given is energy. So that means box number 1 is going to be energy. And box number 2 will always be moles in this case because that's where we're going. The only thing that can come after energy is moles. And we want to know grams. And we've been doing that all day. That's not a big deal. Box number 3 is going to be grams. So even though this looks like a complicated word problem, you can still do it, promise. We drag all of these guys down, and then we plug in the numbers. Given is always first. Always start with what you know. We're going to use the balanced equation to find the next set of numbers going from 1 to 2. All right, in my equation, I've got 456 kilojoules. And if I'm looking for hydrogen gas, my coefficient is 6. That big number in front, that's the moles. And last but not least, we're going to do 1 mole is the molar mass. 1 mole, and we already know the mass of H2 because we did it in the last problem, was 2. 1 and 1 is 2. So we're going to multiply these all up and divide by the bottom. So when we multiply that up and divide them out, we get a whopping 4.7 grams. And we know it's grams because all those other units cancel. And that's all I got for you. If you are still confused, just send me a message.